in full screen slideshow mode. Is that okay? Have you got the full screen?
Yeah, all good.
Okay, great. Right, then just let me know when you would, I don't know, for a few people, it's still only 1 minute past 11. Do you still want to wait for a few people to join?
Well, I think it's up to you. If you can start now, we can start now. I think then people will just hop on.
Okay, right. Good. Then I'll just switch back to full screen. And okay, good. Okay, right. So the topic today is, well, I'll just introduce myself and the co-authors again. And so I already had a talk last week on petroleum systems modeling and the role in a structured exploration process. And I showed a case study, a fantastic piece of work that was done by a company called NIS, a Serbian company in the Pannonian Basin. And I also briefly mentioned a few examples of work that is in some way comparable, just for the petroleum systems part, that has been done in Ukraine. And what I'd like to talk about today is an extension of what I showed last week. And the point here is specifically license block ranking. And this is something that is often done under time pressures. So the problem is, if companies like NIS in Serbia, if they do this routinely, they are fully prepared to rank license blocks. They have all of the information they need. But for companies who don't have this information, and they only have, you mostly only have very little time, you need rapid screening methods to do this. And I'll be showing you an example today. And there are two colleagues. You can see the names here, Tom Levy from the US. I've done projects like this together with Tom. And Dmitry Surovtsev is also a colleague who works on sometimes a little bit more on the theoretical side of decision processes in exploration. And so some of the material I'm showing here is also from Dmitry. A reminder again that what I showed last week already, the probably most widely used structured process in the industry for exploration is called play-based exploration. And if there are any students or young geoscientists who are just starting in the industry, this is a document I can recommend. It's publicly available. You can just search in the internet, Google for play-based exploration from Shell. This is a very nice, concise document. Then also what we talked about last time was basically how to do this properly. And we talked about a structured process that typically companies will use. And we looked at each of these points. We talked a little about data management, how we do the G&G work, how we do petroleum systems work, and I showed this case study from the Pannonian here, and how we use that for a play risk analysis, and how we can then go into a probabilistic assessment and, for example, use the play risk analysis to quantify the undiscovered resources, and basically to build a map of basins or entire countries which give us an assessment and values for the potential undiscovered resources, which is obviously a very important measure for where we would like to explore. A very useful process here. Then we go to prospect risking. Part of this is the geological risk, but we also have the probabilistic aspect. If we're calculating the potential volumes of hydrocarbons in a lead or a prospect, then that is something that needs to be done in a probabilistic manner. It doesn't make much sense to say, well, you know, this might have 100 million barrels. That one might have 100 billion barrels. The important part is the probability. One might have a very similar number to the other one, but the probability might be completely different. So you can only look at prospect volumetrics meaningfully in a probabilistic manner. And then the economic value has to be introduced to the assessment. So you might have a wonderful prospect, but well, it's in deep water. It's hundreds of kilometers away from the nearest facilities where it could be connected. Obviously, that has to be taken into account. So you have the geological risk and the economic risks in prospect assessment. Then all of this feeds into an exploration database, and ideally have companies have a complete portfolio, and the technical staff manage the portfolio, and exploration management can go in any time and apply their criteria and select and rank prospects that are in the portfolio. So this is done, big companies, ExxonMobil, Shell, etc., BP, they do this globally. And we talked last time a little bit about what this looks like and what we have to do. But this is all a continuous process that people are working data management, G&G, petroleum systems, play in prospect risk, and can then develop a portfolio. We look quickly at petroleum systems. That's one of the tools. The important aspect here is that we're not looking at the present day system, but we can look at how a basin or a play evolves through geologic time, because that is what controls the prospectivity. So the important lesson here, and this is part of the Shell play-based exploration strategy, is you cannot look at a prospect on its own. You need to understand the play, the regional contexts, and you'll see that mentioned again and again in this document. If an exploration manager says, well, I want you to look at this group of prospects and determine their risk, that cannot be done without a regional background. Then we talked about the petroleum systems elements and the risks that we have. And so there are terms that I mentioned here. We have so-called exploration risk models. And you will see this is very important for the screening workflows as well. The exploration risk factors are the risk factors that we have in the petroleum system. So we have a source, migration, reservoir, seal. Together, this is the trap risk. These are the risk factors that we need to think about in exploration and when we're building a portfolio. And in order to be able to rank the prospects, and especially if we're operating with a large portfolio, it could be a complete country, different basin types, but we need to have standard risk models to be able to rank the plays and the prospects. So these terms, exploration risk model, risk factors, and corporate standard risk models, these are very important terms here. What we typically do, and you can see the source for this again is the play-based exploration guide, is that we look at two types of, let's just call it chance. One is the play chance. Different terms are used, but the one is the play chance. This is the regional risk, or it's also sometimes called the shared risk, because all of the prospects in an area, in a play, have these common play risks. Then we have what is sometimes called a conditional chance. This is the prospect or the local risk. So maybe, a lot of people, just to keep it simple, say, well, we have two risks. First, we need to understand the regional risk. And then second, we want to understand the specific local risks. And you can see here are the risk factors. We have reservoir risk, charge risk, trap risk. These are the key risk factors. And we can map these, and we can build composite risk maps. Some people call them traffic light maps or play chance maps. And We can then take the local risk and the regional risk, and we can use this to define and map the total geological chance or chance of success. So these are the standard approach, and it is typical in the industry to always subdivide play risk and the local risk, because before we look at a prospect, we want to know if it's in a good area in the play. And that is why you need to understand the regional play risk first in a basin. Where is the best plays? Where are the best areas? And so that you don't waste too much time looking at prospects which might not be in very good areas to start with. So this is quite simple. You always back out and look at the play risk. The risk models, I already mentioned this. We have risk factors, and typical risk models like this one here, they might have 6 factors. They mostly have 5 or 6 factors. And this one is very similar to an ExxonMobil global standard. And it looks very simple, and it's meant to be simple to start with. Then for each of these risk factors, we can define whether we think it is good or bad. And we give it a number from 0 to 1. That's very simple, because when we build these maps, we simply multiply these numbers with each other, and it's easy to understand if one of them is 0. Let's say seal. We assume there is no seal. The number is 0. It's bad. That means, very simple, you multiply something with 0, the whole thing is 0, and that is a very negative rating. You've basically destroyed the play. You're not going to work there because it's 0. It's just a very bad and a very high risk. So we work with a scale from 0, bad, to 1, which is good. The chance of success values. These values that we give it a link to the petroleum systems understanding. We need to justify every value, and we need to, this word parity is important because we need to standardize our approach and the understanding to do this. And I'll show an example in a moment. You'll see how this is done. So the next question then, if a risk factor is 0 or 0%, which means it's bad, or 1, it's good. For example, if we prove a play and make a discovery, that means that the risk factors are good because we know that somewhere in the play it works. The play risk is good then. And there are different risk models that have been published. You can see 2 here, one from Shell, one from ExxonMobil. So there's some very useful papers from ExxonMobil, classic papers. These are still the same people who are running their global risk assessment team, Ken Hood. And the Shell risk model is also very similar. So they might look a bit different when you look at them first, but they're actually exactly the same. So the important point here is here are the risk values here. Let's just look at the Shell risk model. So if we give it 0, remember 0 is bad, 1 is good, and you can see here they're just using exclude. That means if you give it a 0, it's off. And here you go through a scale, extremely unlikely, very unlikely, unlikely, equivocal. If we have a 50% value, that means we don't know. We're just rolling the dice. We really, maybe we have little information, or we have little confidence in the information. But if you say, well, I think it's 50-50 that we have a seal in this area, then you're basically just guessing, but that could happen. That's the way it is. If you feel more confident about a positive outcome, you will give it a higher rating. It could be 70, 80, 90%. If it's proven, you give it 100%. But also, when you go from the scale, when you go down the scale from 50 to 10%, this is, you have to remember too, if you give it a 0, the area is dead. You're excluding it immediately. And the closer you get to 0 or 100, you can see this term here, confidence, confidence. I have high confidence or low confidence. The confidence is also based on the available data. If you have a lot of data, you can be more confident. So if you're not sure about something, you might give it a range. If you feel a bit negative about it, and this is your judgment as an expert, then you might give it 40%. If you feel a little bit positive about it, then you might give it a 60%. But if you are very confident that this factor, for example, the seal quality is good, you might give it a 90%. If you are very confident that it is bad, you'll give it a 10%. That sounds quite simple, but it works very well in practice. And as I'll show you, commonly have a team of experts that work on this, and they also always understand the regional differences, and I'll show examples about this. So this is the basic concept, that you have a range from 0 to 1 for a value, and you modify it according to your confidence or knowledge. You can see here, ExxonMobil and Shell, exactly the same confidence. Increased confidence is based on more knowledge, more data. Obviously, you have 3D seismic. You will have more confidence in the interpretation than if you only have 2D seismic. And it's the same over here with the ExxonMobil risk model. Confidence, high, low. And this is also related to the data sets. Do we have good data? Do we have bad data? This is something we always understand immediately. Oh, I have a lot of concerns because I don't have enough data. And then obviously your confidence, you have to make a decision, but your confidence is not very high. And that's an important part. In the mapping, everything has to be related to confidence in the quality. The result, when you map it, is that you have a risk model. And you can see in this map on the left, this is from, it's a very large exploration area, an offshore basin. And you can see that the team here has done the risk mapping, and they've simply calculated, they put blocks on here, and they've calculated an average. And so you have areas out here, which these are very low, no chance. Then we have in these areas, for example, the red color just gives us the scale. And you can see here, this is in the mean, the values between 0 and 1. So 1 means positive, the risk is low. 0 is negative, the risk is high. And this is a typical traffic light map that is used, in this case for play chance of success. And these play maps are then also used as a foundation for the assessment of undiscovered resources. So if you look at this, this is published by the offshore energy resource agency in the US. And you can see subdivided, in this case, into very large areas. You can also subdivide them into very small areas, but you can see these numbers in here and the color scale. And you can see this is the predicted or undiscovered resources in these basins. So this can be done. I also have examples from Norway, for example, published examples where you can see that this is done in great detail. So it's also possible, there's nothing technically too challenging about it. You could create a map of every basin of the entire country of Ukraine, and you could build a map to show which one has the best potential by following this process: risk, geological risk assignment, and then play chance. That's how you do this. So now we have a challenge. If we have a team like the NIST team in Serbia that do this continuously, or at Petrobras, there is a special team at Petrobras, 15 people in a team that do all of these geological risk assessments full time. But now what happens, you can have licensing and licensing blocks, and we'll look at a few steps. How can you rank blocks, a large number of blocks in a country in a very short time span. And this is something that has to be done all the time. Like I was in Mozambique earlier this year in February, and they have licensing blocks, and companies are looking or investigating this, and what are the ranks. You also have companies in Ukraine that are looking at a lot of different exploration blocks, and you have to decide quickly, how do you do this? The first part, and I'll show you an example here. The first part is that you need to assemble an expert team, and you need to have a range of different skills. And this example is from a project that I worked on about a year ago, where we actually assessed 40 blocks in 3 weeks. So the first person is experienced explorationist who'll develop the strategy. I'll show what the strategy is in a moment and guide the process. These are mostly people that have global experience in many different basins worldwide, and this is mostly to manage the process here. Then on the team, and this is very important too, because we were looking at data in data rooms. So we're talking with the client or with the regulatory authority. We're working in the data room, and it is very important to quickly look at the seismic data. You will see a lot of leads or prospects. And so a very important part here is an expert in sequence stratigraphy who can very quickly, they look at the seismic and they see geology. These people are fantastic to work with. So you need a lot of experience to do this. This is great. Then petroleum systems, because the risk factors that we're looking at are always connected to the petroleum systems. How do they work? What do we know so far? Are we in a complete frontier basin? What do we know about the reservoir distribution, the seal distribution, etc.? So you have a petroleum systems analyst responsible for the risk model. And then you need regional geological experience. You cannot do this without people in the team. We had 2 people in the team here who knew all of the basins that we were looking at, have a lot of experience, and without this level of experience, you can't do this work. So this really requires a lot of experience. Then the team is assembled, and you need to review the data in each block. So we reviewed the blocks, and you'll see here we're looking at 6 areas. In a moment you'll see, and 40 blocks. And we did this with the client team. We reviewed their data. They showed us the data. They showed us interpretations. They showed us the prospects. And we needed sort of roughly a day, up to a day for each basin. So the first week is simply to review all of the basins and blocks. So this is a huge amount of information that the team gets. So you need to have these different experts, and we need to assess regional geology play risks. We need to look at the leads and the prospects that have been defined, and we also need to have a quick look at the volumetrics that have been defined for each of the leads and prospects. And then we go through and use a block ranking methodology. The methodology itself is called multiple criteria decision method, MCDM, with weighted scoring. This might look a little bit theoretical, but I think it'll become clear. I'll explain it in a moment. We have a standard risk model, which is based, we've already looked at this, on the petroleum systems elements. And then we develop block ranking criteria. This will be different for different projects and for different clients, and I'll show an example. And then we do the block ranking, and once we do the block ranking, we can do the areas. We can actually say, well, which is the best basin to work in out of these areas? So we have, and this process, as I said, is done in 3 weeks. So first we'll have a look at a little bit of the theory, the so-called multiple criteria decision method. So we have a lot of different criteria here. So one criteria might be, well, we want to find oil and not gas. Another one might be, oh, we want obviously to find the largest volumes. Another criteria might be, well, but the economics have to work as well. And somebody might be looking for something which can be produced very quickly. They are only interested in prospects which have the potential to be connected to infrastructure. So these are all multiple criteria. And what we're looking in here is we're mostly working in licensing rounds, but this is also the same process that we use to develop our own portfolio. When we're a company and we want to rank the prospects in the country, like UGV might simply want to construct industry standard database that they use to manage and rank all of the prospects in the country and report that to management. So that's called the problem framing step. Then the criteria. We need to agree on the criteria. So this is a multiple criteria. I just mentioned a few examples, and I'll show in a moment what this list looks like. You don't want to have too many. So typically you might have about 6 different criteria, and I'll show what that looks like. Then you agree on the weights. You need to think about which criteria are more or less important, and you give them weights. I'll show this in a moment too. Then you provide the ranking candidate. So what has been assessed, and a critical point here is for the team to be objective. And if you have somebody in the team, like sometimes you have a regional exploration manager, he's pushing for his area. He's pushing for his area to be explored. He wants to get more budget for drilling. He wants more drilling to be done. But he actually should not be on the team because he has a bias. No, it's a positive bias. He wants to be successful, but he's not thinking of the entire corporate portfolio or the entire country, for example. So then you assign scores to each prospect in play, and I'll show you an example here too. You can calculate the total score. It needs to be checked. You need to apply common sense. The team will apply and recheck this. And then you can take a decision. And this will also depend, you can see here, a risk attitude. So a big company might say, I can take high risk, I can look at very big prospects, or I'm only interested in looking at very big prospects, even if they have a high risk. A small company might say, no, that's too risky for me. I can't invest $1 billion in drilling. I need to be looking at prospects that have maybe a better risk, a lower risk, even if they're small. So that is the risk attitude. This also needs to be taken into account. So let's look at this example. So I've had to, you can see I've had to cover up the names of the blocks. Not allowed to give away too many secrets, but we're working in 6 areas. Each of these areas is part of a basin or even a whole basin. And you can see the colors are the blocks, the green colors, the blue colors, the orange colors here. These are all the licensing blocks that have been offered. And there are approximately 40. And our job was to work with the client to rank them. They didn't have an internal process in this case to do quick look ranking. So here you can see each basin, the available blocks, the licensing blocks that are available. So this could just as well be Ukraine. You're looking at a map of the licensing blocks that are available, and you have a lot of blocks that you want to evaluate. How do we do it? So the first part, and I was talking previously in theory in that table from Dimitri, the block ranking criteria. And here are the criteria. This is for the block ranking. So you can see here 4 different criteria. So we have, in this case, this is a standard plot, volumes versus chance of success. Here, this is the chance of success that we've just been looking at, the geologic chance of success, where we look at these risk factors and assess them. The team assesses them. The volumes, in this case too, this is the potential discovered volumes. We get this from, in this case, also from the client. And this is, you'll see in a moment, a plot, expected volumes versus chance of success. And you will see then on the plot, well, we might have some big volumes, but a very high risk, a very low chance of success. We want to have an overview. And this is a very important factor, so we give it a 50% weight. Then you can see what the client is interested in is the additional future potential, because we do not always have, for example, seismic data to identify the leads and the prospects. So they call this upside potential. We might be looking at areas where we do not yet have any seismic data, but this could be very interesting. This client has a longer term perspective, and they say, this is something we want to have included, so it gets a 20% weight. Then, at the same time, the client's in a hurry. They need to have new fields online very soon, and they might say, well, we have a priority. We would like to weight prospects that can be drilled with the present data in the near term, and we give this a 20% weight. Then there's another problem in many of these basins. Accessibility is a problem. We have completely different weather at different times of the year. We can't move equipment. You know, this could be in the Arctic and the tropics. You have a rainy season, and this is important. They want this to be included. So you can see this is very commonsensical. What is important? The top priority is the volumes we want to discover, and we want to have a good chance of success. But then we also want to consider long-term strategies, short-term production requirements, and accessibility, which in many of these blocks is a problem. So we first look at the geological chance of success in selected blocks. So here I had to cover up the names, but each one of these here is a block. And so you can see the team members, 5 experts, the sequence strat expert, the explorationist expert, the local regional expert, and the petroleum systems guy, that's me, and the second regional expert. And you can see here, this looks very simple, but this is the way it's done. These are experts. So we get input and we look for the block. Well, everybody has to do this separately. It's very simple, a very simple game. All of these experts have to do this separately to give them a ranking. So we get information, we'll talk for a few hours and debate, and then everybody has to go and give it a ranking. So let's say in this block here, trap, so Gerhard is a bit negative, Tom is a bit positive, Debnat, the regional expert, is pretty positive, and I'm a little bit positive. Siddhant, the other expert, is also positive. So we come out with a median value here of 0.6. The same for reservoir, charge, seal, and timing. So migration versus trap formation, etc. So this looks very simple, but this is the way it's done. And this gives us then, for each block, this number, the geologic chance of success. So I'm not showing all the blocks here. I've just picked 4, and but this is the process, and it'll take quite a few days, probably even about a week to do this. Then, so we have the geologic chance of success. This is what I showed in the previous slide, and then you can see a table here you can see COS, chance of success. So we're multiplying, so most of the numbers are relatively low. We're on a scale here of close to 0 and going up to 0.3, which is pretty good. And then we have the potential in-place resources, which have been assessed in this case by the client. So this is, they've looked at prospects in every block, and we receive that information. And so this is very simple. You can see this is built in Excel. In place, HC volumes versus chance of success, the vertical axis. We have a distribution all over the place. And you can see here we've assigned these numbers and classification. So this is also pretty simple. The 1 is our classification for something that is poor. The chance of success is not very good, and the volumes are low. So this is our area where we have very poor. The other extreme is a rank over here in this area where we have good chance of success and very high volumes. This is obviously something that we're keen on, and so this feeds into this classification, and this will determine this value. So this can be a little bit semi-automated. All the data is just, in this case, handled in Excel, and we use this to determine hydrocarbon volumes versus chance of success. And then for every block, the team discusses with the experts upside potential. So I've worked in many of these areas already, so I also had a good idea. Ready to drill prospects and accessibility. And the result is, so you can see here is the block ranking criteria, that we have the blocks in here. You can see these green areas and the orange, purple areas in different plays. And then you can see our total ranking. So this one up here, this is very poor. So I'm not showing here, I can't show you which specific factors were negative, but we ranked this block as very negative. This one here, the highest value, number 5, in this case, we didn't have any 6s, but this number 5 here, for many different reasons here, chance of success, expected volumes, upside potential, ready to drill prospects, accessibility, this one gets a 5. And so this is then the process. We determine, we don't look or we don't create the maps. We just work with the data, probably for a week, and then we can go through the process and determine the numbers and then review and cross-check everything again. So also again, this is a block ranking. So you can see that out of the roughly 40 blocks, so I can't show the names here, the names are hidden, but you can see that 4 blocks look very good. So remember, I'll just flip back. This is where we start. We have no clue when we start, 40 blocks. And then we go through the process. We can see that 4 blocks have a very high ranking with these criteria. Also, there are probably 1, 2, 3, 4, 5, whatever, about 8 blocks we can forget. It's just not worth looking at them. There are some reasons in those blocks that just exclude them. But once again, you can see the important point here is to define a process. It needs to be standardized and followed, and you need to have an expert team that looks at the data. That's the block ranking. So what we can then also do is rank the areas. So here, you can see here, this is the area ranking, volumes versus chance of success. And here we've changed it a little bit. So here you can see we have 5 criteria, and this one is new. Remember previously we had volumes versus chance of success. We had the upside potential, future potential. We had can we drill quickly? We had accessibility. And now, if we're looking at an area or an entire basin, we include the number of high rank blocks. And this enables, so we want to look at the blocks, and then we can also look at the areas. So we can see here very easily, we have the 6 areas or 6 basins. This one looks good. So if management wants to know, let's forget this area or forget this basin completely, then this one, for example, this is not going to do much for them. In this area here, this is quite interesting because we have we can identify 2 clearly defined areas. The northern part, which is so we have to subdivide this area here. The northern part of this basin, very low prospectivity. The southern part looks very good. So we actually have 3, these are the 3 highlighted areas. This one is good, the southern part of this one is good, and this one is good. And that's what management want to see. So managers will simply say, well, why are we in here? It's not worth looking at prospects in here. No, we really need to concentrate on these. And so that is the way the blocks are filtered. Okay, so now just look at the methodology again. Now you can see a little bit what we've done. When I showed this the first time, it was just theoretical. So we're operating in the licensing round. The criteria. These are the criteria. So I'll just flip back again. Here you can see the criteria. We started for the block ranking with 4, and then for the area ranking, we had 5. This is the criteria. The weights. The weights are the numbers here. So here, this is the most important one, to have the volumes and a good chance of success. And these are the other weights. These are the weights. Then we go through the assessment. This is done by the team. We assign scores. And I showed an example for the chance of success as one of the scores that are assigned. We can calculate the total. This is what we use for the ranking table. So this table is then this table here, for example, or overall block ranking is based on this total score. But we have to review everything again. And you see again and again, oh, there's maybe a mistake in the data, or there's been a misunderstanding. So this is then reviewed by the team. And then you can take the decision here, the final point. So that's the way it works. And I'll just summarize the key points. You need to assemble a small team of experts and follow a very well-defined, a very clear strategy. This is you can see this is a very simple method, but it's very widely used, but it depends completely on the expertise of the assessment team. Data room sessions. This is also critical because in this case also we're working with a client and they have already done a lot of work, and we've been called in to help the client to do the evaluation quickly. Which are the best blocks? Very quickly. And the methodology is called multiple criteria decision method with weighted scoring. You can now understand what this is. We have multiple criteria and we weight them. So some criteria are more important than the others. Then everything is based on the petroleum systems assessment. We can then develop block ranking criteria, block ranking summary. And I also showed at the end how we can take the block ranking information and, if required, summarize that for each area or basin. So it's a very intensive, we had, so for the example I looked at here, there were 5 people working non-stop for 3 weeks to do this. And this happens. Sometimes you just need to provide information to management quickly, and this is possible. Okay, so that's the talk. Once again, my email address if you have any questions. And oops, sorry. So I'll leave this up here. And if you have any questions now, then just let me know. I'll just cut this down. And yeah, keep on sharing this. So if you have any questions now, let me know. And I can also, oops, I need to look. Okay, I'll back out. And let's see, there should be a chat box somewhere. I need to switch it on. There it is. Okay, so if anybody has any questions, you can either type them here in the chat box or ask questions directly.
Hello.
Yes.
How are you? It was an interesting question. I have one small question about it. When we were talking about the risks, each and every one of you were making risks, the percentage, let's say
Yes.
0.5, 0.6. What would happen if there would be a big difference between you guys? Like we're talking about from 0.1 to 0.6, so excellent and not good at all. So what would happen?
That's a very important point too, because first, those numbers are done separately. Every expert on the team, we go away, we split up into, we do this separately, and we put all the data in the table. Then we show the data to the whole team and decide what to do. And the question you ask is exactly what happens. Every now and then, you see a number which is extreme or an outlier, and you have the chance to discuss that again. So this happened quite often. We saw in, I think probably the most common issue is that there has simply been a misunderstanding when the regional geology expert talks about something that, let's say, the petroleum systems expert or the sequence strat expert has maybe misunderstood something, or it has to be clarified. And so then you have a chance, if there really are outliers and the team can say, well, this is a mistake, then it can be corrected. But it's an important question because it does happen. And then you need to have an open discussion, and then the team decides, well, that outlier might be justified, we leave it in. And obviously it will change the overall value, but that's the way it is. That's why you have a team, and you typically have, in order to reduce the effect of the outliers a bit, you can see in this case we had 5 team members. And it's interesting too, because the US Geological Survey use a similar approach for a lot of their global resource assessments. They have a so-called Delphi method, and they also have a small committee of experts, and there's not just one person doing this. So you need to have some equilibrium, but it happens quite often, and it's a very important point. But that is then part of the review, because there could be a mistake. It's not just the one person who has a low or high value. There could be an overall misunderstanding of the criteria, and that then maybe needs to be clarified.
Thank you very, very much for clarifying.
Okay.
Hello, Bjorn. Can you hear me?
Yes.
My name is Branimir, and first of all, god påske till dig.
Sorry?
God påske till dig. I presume you are Norwegian by your origin. Okay.
Okay. Yeah, it's very confusing because my father was Norwegian, so my first name is Norwegian.
Yeah.
But
Okay.
then if you go back, the family name is from Poland originally, and
Okay.
but so I also heard in Ukraine that it's a word that exists in Ukrainian as well.
But anyhow,
And
I just
it's
wanted
very
to say
confusing.
that I came from Norway here, and I spent now 2 years in Ukraine. The only problem which we have here, compared to Norway, where we use, thank you very much for your excellent presentation. I really appreciate it, because the procedure you presented probably different we use in Norway when I was working in Bayerngas. which is
yes, yes.
and we managed to get about 100 assets. What was amazing is in 7 years.
Yeah.
So that was fantastic scores based on the procedure you presented. And I was occasionally part of the team because I'm reservoir engineer. I'm not geologist, production engineer.
Yeah.
So that is really procedure which gives results, and you demonstrated very well that. The only problem is now how I see in Ukraine. The people are very smart, brilliant, and so on, but the data, the procedure, how data collected for 30 years or more, 40 years of brown fields and the new fields to come are not very well defined. For example, seismic is mostly not the highest quality. It has a quality, but if you want to derive anything from seismic data, then you face a lot of problems, any parameters. Then further production, I don't want to go, there is very well known. So somehow for them, it is important that this procedure is put in place, and probably the old data should be collected accordingly to the best of the future assets. The old asset has another challenges because we were trying, or I was pushing, that we go to the reservoir complexity index more on the reservoir and production side. But it was very difficult to start with because when we face all the data, so at the end I have just a quadrature or a square where I put the highest percentage of PVT or seismic or petrophysics and say production data, and that was all we can do. But what would be your advice for this poor data? And also, because you are now Schlumberger, and I used to be Schlumberger for 7 years. I was in Schlumberger all around. I was in Western GECO, by the way. I was resident for the seismic.
Yes.
And then I was in Abingdon in SAS, and then I was in Schlumberger Moscow Research. So basically, the problem is here, what and how to help and to push that, how we can deal all this with the data we have. That is the only, and what would be your advice for that?
Yeah, the data. Well, first for Biogas, you're absolutely right, and they did a fantastic job in Norway, and I think they had a very clear, very structured approach, and well, you'll know the story, but the interesting part in Norway is that the NPD, they do a fantastic job of reviewing the geology and marketing the assets. They give away a lot of information, and that has enabled them to attract a lot of companies to invest. So Biogas was originally, as you know, a utility company with electricity generation and gas supply company. And the conditions were so interesting in Norway that attracted them to invest in Norway, and they became a very successful exploration company. So that's, for me, that's very important. How do the regulatory authorities work in a country to encourage investment? And that is a big job that Ukraine has as well. You want more people to come in to invest. And so the point that you mentioned about the data is critical, because you have a huge amount of legacy data which is not even digital. And I know because I've worked with a couple of students, I mentioned them in the talk last week, who are now with Naftogaz, and they had a huge effort just to find the data and digitize the data. That is definitely a big problem in Ukraine. And what that means, in effect, when you follow these processes, when you're, for example, ranking the blocks, is that you just have much lower confidence in it. And then you end up with more values. If you look at the Shell and the ExxonMobil, these standard risk models, your confidence is lower, and you're more on the whatever, let's say the scale 0.4, 0.6, and it's not very positive or very negative, but that's the way it is. That's the way the concept works. And so for us too, in this project we worked on here, and this 40 block assessment project, there were also basins which had thousands of wells and a lot of data, but there were other frontier basins included. And in that case, the confidence was just different. But the point here is with the the multiple criteria decision management process, that you need to have some fixed rules and you follow them. So the lack of data will feed into the process. It's taken into account. It's part of the confidence. But it's critical that that confidence go into the equation. But you as an expert, or the experts on the team, will put that automatically into the process, because these numbers are never absolute. There is a confidence factor involved. So it's a big topic, but you're right, because in Ukraine, what would be needed is really a massive effort. And I don't know if you saw the talk that I gave last week, where I showed...
No, unfortunately not.
Okay.
When I saw your name, I just got in.
Well, if you're interested, I can repeat that for you, because it's a very nice example.
Okay, I will appreciate that.
Just send me an email, and then we can do that. And because the problem there in Serbia and the Pannonian Basin was very similar. They have about 3,000 wells in the area, and but a lot of the data was useless, so they had to go through a quality control process first to check the data before it was even digitized. You don't want to digitize everything. A lot of it you will never save. So well data, for example, the datum's incorrect, or you just haven't got... It's the same for the seismic data as well, but you know all about that. But what would really be needed, I think, in Ukraine is a seriously concentrated effort to filter out and clean up the data and to work with it. That's the foundation. Then your confidence will be improved. But then in Ukraine, you also have other challenges, which we didn't have in this project here, is that you have a lot of leads and prospects, which are in a way unconventional. So you have tight gas, and then the volumetrics assessments. The process there is also, let's say, a little bit different. It's definitely more complicated to work with. And so you're also dependent on what do we do with the seismic data. There is, in quite a few areas in Ukraine, you have new 3D seismic data that's been acquired. That's very good quality. But the process of getting a realistic assessment of the volumetrics in the prospect, that is also quite challenging. And we've done work for clients in Ukraine where we actually do that. But that you also need to be very careful with that as well. So there's a huge amount of work and potential in Ukraine as well.
But you know, as I told you, I was 2 years working in the matter of fact in UGV. And the problem is that volumetrics is, they say the source is well testing, but this is not well testing. It is collecting of data at the surface, and then when, I don't know, whatever measurements device doesn't show any oscillation of pressure, then you stop it. You never reach boundary condition, thus you are not able to see any volume properly. Error is probably more than 10%, definitely over 20 maybe. So basically, the first idea is that what is volume in place, then what is the recovery? And then of course, by knowing more volume in place or better calculating volume in place, then the question is the recovery could not be repeated. So that means first of all, I like the presentation because you open the door of risk analysis, of probability. What UGV or Ukrainian environment, petroleum knowledgeable environment, because I respect that environment, but still the processes are as they used to be, but they have to change and adapt to the probability and to the stochastic processes. That is my...
Yes, no, I agree.
It.
Yeah, no, I agree. I've been in Ukraine several times now, and on some of the trips, my colleague and co-author of the paper here, Dmitry Surovtsev, has been with me, and we've had workshops. And the point there is exactly what you've said, that we really need to improve our ability to use probabilistic methods, and to standardize those processes to be able to rank the prospects. That's a problem. Otherwise, exploration is very erratic. You drill here, you drill there. There's no real portfolio management in place. So that's an important topic. Also, if you're interested in learning more about that topic as well. It's very easy for us to arrange calls. And Dmitry is based in Moscow, but he works for us globally. And as I said, I've been with him in many countries. We were in Algeria together recently. And so if that's a topic you're interested in, the probabilistic assessment methodologies and prospect ranking, we can easily set up a call with Dmitry as well.
Okay, but I will be, because now I'm even positioned at the university. So with this position, I have more open possibility. I'm still running my private company from Norway, Petrobrell Energy.
Ah, okay, good.
It seems to me I'm by myself. So it's I survived the worst part of the crisis. So I think, as I said, it is a huge potential. This is not a small amount of, you have 20 million equivalent oil of or hydrocarbon. It's a pretty huge amount of production. And the people, as I said, are intelligent, they can learn fast, but they need, as you mentioned, processes and probably technology and further data. With this, it will be pretty nice and enjoyable for all of them for their future, because they have to survive next 40 years, whoever is newcomer in this environment. But but anyhow, thank you very much.
Very interesting. But what as I said, send me an email so I have your contact information. And as the first step, what we can do very easily, I can show you the case study that I presented last week, because I think it is very, very good. The work that the Serbian team has done is fantastic, and we can show it. It's all public. We have permission to show it, and I can show you that. And it's really good.
I also gave last week, in the matter of fact, lectures on multi-fractured horizontal well, but they put that in a drilling. I was talking about modeling of the well flow into the system, so which is reservoir simulation practically. And then I moved to the unconventional. So that was because when I was before buying gas, I was in IFE in Schlumberger Institute for Energy Technology. That's made Olga.
Yes, of course.
Mathematical modeling building. And I made a software simulator for multi-fractured horizontal well, which is my analytical. I never had it, the Mike Tabenyahu, he SAS director in Abingdon, he made the software great, but I finished with multi-fractured horizontals.
That's good. Yes, I know Olga as well. It's really, really good.
Yeah, but anyhow, thank you very much. It's
well, thanks
very
very much.
Good lectures you provided, and I'm glad that that audience have an opportunity to hear you.
Okay, well, I'd like to thank the organizers again too for setting this up and for inviting me. And it's good. It's also, I'd like to thank you for your comments. It's always good to get some feedback too. That's great.
No, but I think that that Bratach made very good move, and congrats to him. Yes.
Good. Okay. Very nice to talk with you, and looking forward to getting your contact information and an email.
Okay. Thank you very much indeed.
Thanks very much.
Bye.
Bye.
Cheers.
Bye. Bye.